All right, in this video, I'm just going to review this problem from the problem set that I know people had some trouble with. So it talks about someone rolling their bike, riding their bike over a piece of gum. So if you think about it, you have the road here, you have the wheel of the bike. The piece of gum is like somewhere on the edge here. Okay, so we know when the time was 1.25 seconds, so we're imagining here like it's some kind of stopwatch at 1.25 seconds, the gum was at its maximum height. Well, since the diameter of the circle is 68 centimeters, and it's not said, but a wheel, in order to turn, has to be on the ground. So at 1.25 seconds, it's at 68 centimeters. So that's the first point on the graph. And then 1 second later, I'm sorry, it was on the ground. So at 2.25 seconds, the gum was, it was at 0 centimeters. So we know that this is going to be a sine or cosine graph, or you could really write either equation, but we know that because it's a circular motion. So first thing we'll do is we'll define our variables. So we have time, and that's just the time the wheel was in motion, and that is going to be measured in seconds. And then we have the height above the ground. And it's good to be very clear about what we are measuring. So the height above the ground, which is measured in centimeters. This does not have to be a perfect sketch. This is just to get ourselves kind of wrapped around what's going on. So if this was 1 second and this was 2 seconds, and then down here, say this was like 20, 40, 60, 80, so 40, 80. So we know that we have two coordinates, 1.25, comma 68. So we'll just kind of estimate that right here. It's not a terrible idea to write the coordinates so that we're more clear as to what they are. And then 2.25, comma 0. We know from here, because again, the nature of this scenario, it's a wheel, it's going to keep spinning, it's going to always go back up to 68. If he's riding his bike at a constant rate, which is given in the problem that he is riding his bike at a constant rate, then every second it's going to do one spin exactly the same. So, or it's going to do half a spin, actually. It's going to go from top to bottom. So we know that it's going to continue. So we can see here that this is giving us a cosine graph. So now we just have to find the parameters. So the diameter here is 68. If we weren't talking about a diameter, we could just find the distance from the top to the bottom. So just the maximum to the minimum, so a difference of 68. That means that the amplitude, or the radius, is going to be 34. So the distance from the top to the middle, or from the bottom to the middle, is going to be 34. Now, since the bottom is at 0, 0 plus 34 means this line will also be at 34. The middle and the amplitude aren't always the same. The only reason they're the same here is because the bottom is 0. And in most situations, the bottom is not 0. So then once you find the amplitude, you would have to subtract it from the highest number or add it to the lowest number. We can check to make sure we're correct, because 68 minus 34 puts us at a midline of 34. 0 plus 34 puts us at a midline of 34. So we know that the amplitude here, which again comes from the, I'm not spelling it right, comes from the radius of the circle, amplitude is 34. And we know that the midline is also 34, again, just in this situation. Now let's look at, if we're looking at a cosine graph, then we're going to start from either the maximum or the minimum. It's clear that we can easily start from the maximum here. So it has a horizontal shift of 1.25. So it starts at 1.25. It does not start at 0. So it doesn't reach its high point at 0. It reaches its high point 1 minute, or 1.25 seconds after the start. And then the final thing we have to do is the period, and leading that into the B parameter. So the period is the time it takes to go back before it repeats again. So back to where it begins. So from the maximum to the minimum is only half of the cycle, right? It's from the top to the bottom. The full period is when we go back up to the top again. If it takes 1 second to go from the top to the bottom, it's going to take 1 more second to go back up again. So the period is 2 seconds. So again, this image, the information we're given was only half of a period, and we want to make sure we get a whole period back to the starting over. Okay, but that doesn't give us the parameter. We know from the work that we've done that 2 pi divided by the period is what gives us that factor, that multiplier, the thing that we multiply the input by in order to stretch or compress it horizontally in the amount that we want. So 2 pi divided by 2 equals b. We see that 2 divided by 2 makes 1. So we're left with 1 pi or just pi. So we could estimate that to be 3.14, but then it probably wouldn't work out as nicely. So we are going to leave it as pi. Now, writing the equation seems to be where people are getting lost. So I'm going to do that right now. So we have the cosine. So we know it's cosine because it starts at the maximum. It would also be cosine if it started at the minimum and was upside down. The only time it's sine is if it starts in the middle. So it would start on the midline. The amplitude is 34. Because it starts at the maximum, it's a regular cosine. It's a positive cosine graph. If it had been upside down, it would have been a negative cosine graph, and we would have made the 34 negative. Let's leave kind of the input for now. So 34 affects the output because it affects the amplitude, and it is a y value. It affects the size of the graph, which is why we are multiplying. Now they're both 34, but the midline, K, represents the location. Moving this line, this red line up and down moves the location, not the size. And that's why we add that number at the end. So multiplying to change the shape, adding to change the location. Both of these happen to the output of the function because they all come from the y-axis. This 34 and this 34 come from the radius of the wheel being 34 and the fact that the center of the wheel is 34 centimeters from the ground. So that's what those two 34s represent. Now, the horizontal shift and the period are about the time, right? We started talking at time equals 1.25 seconds. That's when we started getting information. That's when this whole scenario began. So that's where this 1.25 comes from. And then it takes 2 seconds for the piece of gum to get back to its original location. So that's where this comes from. Since both of those have to do with time, they have to do with the input. A shift means we just move it over. So we do x minus 1.25 because this is on a 1.25 second delay. It is 1.25 seconds behind the parent function, which would have started at 0. So if it didn't happen until 1.25 seconds, we need to subtract those 1.25 seconds where we weren't doing the problem yet. And then finally, a horizontal stretch or compression comes from multiplying by a parameter inside to the input. So that is pi in this case. Again, because the parent function is 2 pi, the relationship between the period and the parent function, or this number, this b value here, there's either a pi in the period or there's a pi in the b because of their relationship, because of the fact that when you multiply them, you get 2 pi. So here's your equation. This is not the only equation. You could have written a sine equation if you decided to figure out what this point was right here, but we wrote a cosine equation. The way we check that we are correct is we go to Desmos. We click the graphing calculator. We type in the equation right here, y equals 34 cosine pi x minus 1.25 plus 34. That's a typo. Let me fix that. 34. Then we go to here and we check to see if it matches the data that we were given. So we can really spread it out. So we can see that at 1.25, it's at a height of 68, which is what was given in the problem. And at 2.25, so 1 second later, it's at a height of 0, which was given in the problem. Because it matches these 2 points, then we can feel confident that we have the right answer.